This is chapter 5, section 2, thinking mathematically. And so now we're going to focus on number theory and the real number systems. Specifically, we're going to look at the integers and the order of operations in section 5.2. Okay, so our objectives are to define the integers, then look at a graph of these on the number lines, then use the greater than or less than symbols, and then find the absolute value of an integer, perform some operations, and then look at the order of operations so that we're in agreement with how to achieve values. Okay, all right, so the integers are the set consisting of the natural numbers, 0, and the negatives of the natural numbers. Okay, so 0, 1, 2, 3, 4, 5, and their negatives, -1, -2, -3, -4, so on and so forth. The addition or the positive sign is for positive numbers, and the negative sign or subtraction sign is for negative numbers. On the number line, we start with negative numbers on the left and increase in order or value to the right. So notice that -5 is a smaller number than -4, because as we go to the left, we get further from 0, and that means we're getting to be a smaller number. So that's probably one of the most confusing things about negative numbers, is that the larger the negative number, actually the smaller the number is. And as we go to the right, the numbers increase in size or increase in relative order, if you will. Okay. All right. And we notice that when we go to right, the numbers after 0 are positive and the numbers to the left are negative. 0 is the only number that is neither positive nor is it negative. All right. Graphing integers on a number line. So we wanted to graph -3, 4, and 0. Okay, then we would draw a line and then take off equally spaced marks. So one thing that I see common mistake is that we make our slashes here, the distance between the numbers, different lengths. And so we should be very cognizant of the fact that these numbers in some sense represent a distance. And so each of the tick marks need to be the same distance from each other. And so in that case, then from 0, we draw 0 in the center. 3 tick marks to the left would indicate a -3. The center could be 0, though you don't have to place 0 in the center. 0 can be placed anywhere. It is common for us to place 0 in the center. And then we're looking at B. We wanted to create the number +4. So 4 tick marks to the right of 0, 1, 2, 3, 4 would then be the place for our location for +4. Using the symbols less than or greater than, let's look at the graph. So the graph of -4 and -1 are graphed below. If we look at that value, then one should note that in this case, as you go to the left, these numbers are smaller. So -4 is actually less than, so this is the less than symbol, than -1. Okay, which is what we're showing here, but I'm writing it on the actual number line here because it's further to the left. So the further to the left the number is, the more negative it is, or the smaller it is. Okay, and so that's one way of discussing that. Or we could say then this symbol means less than and less than. And you can remember that in some sense because it sort of makes an L if you think of like your hand, like this is your index finger and this is your thumb, and this is your fingers. It kind of makes an L for less than, and so that's kind of one way to remember that this is less than. The other direction is greater than, so this one here means greater than. And so we can equivalently say that -1 is greater than -4, writing it in this notation here. So -1 is greater than -4, or we can say -4 is less than -1. All right. All right, let me clean those off. And then we can talk a little bit further about the inequality of these symbols as well. Okay. So these are called strict inequalities because there's no equality option available. They are strictly less than or strictly greater than. An example, if we wanted to include that here, -4, if we look at our number line, -4 is over here, and we have -3, -2, -1, 0, 2, and 3. And so since -4 is further to the left, we know that it is less than 3. Okay, this one is tricky because we normally would think 1 is a smaller number than -5, or is smaller than 5, but and that's true in the positive sense, but these are negative. So remember, -1 is like right here, -5, that's not the right place for it, -5 is right here, and so it is further to the left. So actually, -1 is greater than -5. Okay, what do you think about -5 and -2? Well, if you don't see it, here's -2, here's -5, so -5 is less than -2. And here, 0 is here, and -3 is over here. Okay, so again, -3 is to the left of 0, so 0 is greater than -3. Okay, so it's really helpful to draw the number line out. You can really start to see the visual placement of each of the numbers, and that can help you, especially as you get through these kinds of problems where they're trying to trick you with -1 on the left and -5 on the right, or 0 on the right or on the left and -3 on the left or on the right. If I could say words, that'd be helpful. Okay, all right, let's go ahead and jump to the next problem then. And here you can see how they're, again, utilizing the number line here to indicate which ones go where in the explanation. Okay, all right, so now we get into the inequality, the quality or the equal part of this. So A is less than or equal to B. Here we have, again, if you think of the hand, here's your index finger and your thumb. Okay, then this is less than. And then the little line underneath of it here is indicating the equal to. So it's less than or equal to. This means that A could equal B, or A could be less than B. A is a smaller number, or it's equal to B. And this is B is greater than or equal to A. So here, B is either equal to or greater than A. Okay. All right, moving down. The absolute value, denoted by these vertical lines here of a number, represents its distance from 0. So if I look at, let's say, the number -5 here, what that's saying, if I look at if I want to know what is the absolute value of -5, what is that saying? It's saying how far is -5 from 0? It's talking about this distance here. And since we always consider this distance, that distance to be positive, the absolute value, or if you're talking about like how far you had to walk, would be 5 units. Okay, so the absolute value of -5 happens to be 5. And if we look at, let's say, this direction going in the positive, here's +5. This distance, again, the absolute value here of +5 is still referring to that distance. And that distance, again, is going to be the same value. It just so happens to be that the value of 5 here is positive. And I don't know if this helps or not, but the way that I can also think about this is the negative sign. The negative tells you direction, tells you, that's a really bad U, direction. I think if we were more careful, we would write this as a +5. And so the plus or minus the positive and the negative just tell you direction. So if it's a number out this way with the positive, it's just telling you that your number, the way that you need to go for your number is to the right. And if your number is negative, if it has a negative sign on it, then the number you need to go, or the direction you need to go, sorry, is to the left. Okay, so if you think about the sign in front of the numbers to the right or to the left as positive and negative, then all they are is a direction. And so the absolute value doesn't care about the direction, it cares about your distance. And that's what it's asking you is how far away are you? Okay. So if that's helpful, that's another way to think about distance in the absolute values and direction. Okay, so direction again would be represented by the sign, whereas the absolute value doesn't care about the sign. It doesn't care what direction you're heading. It just wants to know how far you went. Okay, so direction versus distance are two important ideas to think about here. Okay. All right. Let me go ahead and get rid of that as well. All right, so let's consider then this example. So finding the absolute value of -3. Well, at -3, the absolute value, again, we're not looking at the direction. We don't care about the direction. We're just caring about how far you walked or how far you went. And so the absolute value of -3 is 3, whereas the absolute value of 5 is +5. Because again, +5 would be the direction here. But the absolute value of 5 just says, okay, you went a distance of 5. And the absolute value of 0, of course, is 0. That's saying I didn't go anywhere. All right. So actions on integers in terms of like addition, for example, if you add two numbers together, so again, going back to the direction analogy, so if you are over here, let's say at 0, and you walked this far, -11, and then you wanted to say, oh, okay, now not only did you walk to -11, but then you're going to walk another, and I'm trying to make this just a little bit longer, but I exaggerated a little bit much, another 15 steps. And you want to look back and go, well, how far did I walk? Well, you're going to add how many steps did it take you to go here, and then how many steps did it take you to go there, which would be a total then of a -26 steps. So you went 26 steps in this direction, and that direction is negative. Okay. This scenario is very similar, but here you happen to be changing course. So at first you started at 0 and you went negative 13. You went 13 steps in this direction, so you went a -13. But then you said, oh, I need to turn around and go back the other direction. I need to go back the other direction. In fact, I need to go back four steps this way. Okay, so here you went +4, whereas here you went -13. So you went 13 steps this way, and then you said, oh, I need to change direction, go 14 steps back this way. And so where do you end up at? You end up back at a -9. So -13 plus 4 means you're at -9. Okay. And now this scenario is actually very much the same way. It's just for in this situation, here you started at 0 and then you went distance of 13 steps. So here you went +13. If you can pretend with me for a second that's a +13, then you said, okay, wait a minute, I forgot something, or maybe I dropped something back here, and I need to take 7 steps back in this direction. So here you went 7 steps back this direction. So where did you end up at? Well, oh no, sorry, 6, I said 7. You went back 6 steps this direction. And so where did you end up at? You ended up at a +7. Okay, so you went 13 steps in the positive direction. Then you said, oh, no, I need to go back. And you then turn around and walk back a total of 6 steps. And so if you ask yourself, where are you relative to where you started, you're at a +7. So those are some of the ideas about how to think about when you're adding integers. You want to be careful of the direction that you're heading. And if you can always think about it in terms of direction, it will significantly help remove some of the confusion about, when do you add, and why does it feel like you got a smaller number when you added two numbers together, or why do you ended up with a bigger number when you thought you were subtracting? So, here's some tips to pay attention to. I'll let you read through that and make sense of that on your own. All right, additive inverse is what is that saying? That's just a fancy way of saying, if you tie your shoes, how do you undo that? How do you get back to the state of not having your shoes tied? Well, you untie them. Okay. And so this additive inverse thing is just it's the thing that you do to undo what you have done. So if we've added something, the inverse operation, the additive inverse, we call subtraction, or we say additive inverse. But it's the conception that if you start here at 0 and you go one direction, okay, some distance, let's say A, okay, and then how do you get back to 0? Well, if you wanted to go home, right, you would have to go back the other direction. So you walked in the positive direction A units. So to get back home, you're gonna walk in the negative direction A units. So the additive inverse is the equivalent of undoing or walking backwards the same distance in which you walked forward. Okay. And 0 is the additive identity. So meaning that A plus 0 is, well, that's equal to A. It's not going to change anything. Okay. So I think that covers the ideas here fairly well. There is some concern about, how do you, okay, I'll go ahead and move on. For all integers a and b, negative or a minus b is the same thing as a plus a negative b. So this is just a saying that you can add the additive inverse. So subtraction is the additive inverse of this. So just keep that in mind. All right, so subtract. So 17 minus a negative 17. I still think that the idea of this is helpful to think about distances walking. So if you started here at, let's say 0, and you walked out here 17 units, so I'm looking here at A, okay, so you walked in the positive direction, so that's positive 17, and then this is saying that you were going to turn around and change the color here. It says, okay, well, you're going to change direction, and you're going to head in this direction negatively. You're going to turn back and walk this way, but you're going to do that in a negative way, right? So it's saying turn around and then turn around again. So this is turn around. The negative sign means turn around, but then you turn around again. So this is the first negative. So the double negative means that you are no longer facing that direction. Now you're facing this direction. And so you're going to then go a negative, and a negative means that you're going to end up going in this direction another 11 steps because you're heading in the positive direction. So that, again, the negative and the positive signs just give you direction. They're telling you which way to go. The negative means you're heading in the opposite direction. And then if you do that twice, right? So if you're facing this way, and then the negative sign comes along, boom, and then you're facing this way, okay? And then another negative sign comes along, boom, and now you're facing back in the same direction in which you were originally. Okay, so the double negatives like this mean you turn around once and then again. So you turn around twice. So you do a full 360 here. All right, let me erase all this, and let's then look at, all right, how does that play out when you have something like this situation here? Okay, so how does that play out in this situation? Well, in this situation, okay, you're over here at a negative 18, meaning you started at 0 and you walked this way, originally negative 18 steps, because again, the negative says turn left, okay, or turn around. And we always assume that we're pointing to the right, okay, and then you're here, and then the negative 5 says, are you ready for this? It says turn around, okay, so you're here facing this direction originally because you're heading in the negative 18 direction, okay. Let me see if I can add a little bit more room here. Okay. So originally, let me start up here. So originally, you're facing this direction because you're at the negative 18, right? If you just got here. Then this says turn around. Okay, so then now you're facing this direction because of this minus sign right here. Okay. And then this says, oh, wait, you know what? I forgot. Nope. You need to turn around one more time. So finally, then this one is saying, oh, I'm heading in this direction. Everything I just said is wrong. It's hard to draw on this one. So let me redo this up here with a clean example. Okay. It's hard to draw this. All right. All right. So you started here at 0, and you went out 18. Okay, so this was over here at minus 18. It said go negative 18. Okay. Then this says, oh, you got to turn around. Facing this way. Turn around. Back around. Hmm. Yeah, that kind of breaks down here. Let me think. Okay. So you head out here to negative 18. And then uh, these two signs together mean that you're going to end up heading back this direction, a positive 5 units. Okay, and so you end up here at a negative 13 when you're done looking at the results. Okay, that's hand waving, and I'll just ignore that. Okay, all right, well, moving on. Multiplication of integers. So here we have the product, which is the number of times that you're adding an integer together. And so in this case, what it's saying here is 3 times negative 4 means that you have 0 plus negative 4 plus negative 4 plus negative 4. If you think about this on the number line, um, here's 0, and it's saying you have 3 copies of negative 4. So you have a negative 4 here. So there's one copy. You have another copy here. And then you have another copy here of negative 4. And so when you're done with all that, it asks you, what is this position? Well, if you just add each of those up, negative 4, negative 4, and negative 4, you end up at negative 12. And that's the location of this spot here. So the number line here, again, all this is telling you is, this is telling you how many of these you have. Okay. All right. Well, what about something like this? Why is a negative times a negative a positive? Okay. So let's just explore that a little bit here and consider the following example. Okay. So what it's saying here is that um, we start at 0, okay, and it's saying that you have a negative 4. You still have those 3 copies. That's what it's saying. And I was trying to make them all the same, but hopefully that's okay. All right, so you're still over here at negative 12. But then it's saying, oh, look, I have a negative in front of this one. So it didn't want it in that direction. What it's really saying is I want it in the opposite direction. So whatever that value was, can you mirror it or reflect it about the positive axis here? And so what it's really referring to is uh, I want to know what this is. And so in other words, it went hop a -4, hop a -4, hop a -4. Oh, but I actually want it in the opposite direction. So the opposite direction means that you're going to hop to here. So in reality, you actually have a positive 12, the negative 12 that we had last time. Okay. So again, the negative sign here is exactly the same as this operation, but instead it's saying, okay, I want 3 copies of that -4, but I want it in the opposite direction as the previous one. Okay. All right. So hopefully that makes sense with the negatives and the positives and the number line, how they can help you to make sense of. Okay, so the first number just tells you how many copies you're going to get and also the direction that it wants those copies in. Okay. All right. And so here's some multiplication rules. If you want to, if you're more comfortable like with memorization techniques, you're welcome to memorize these. I prefer to think about them in terms of the number line and which direction I'm heading. That way I don't have to memorize rules. I can make sense of it through reasoning. Okay. But these are helpful. And as you practice them more and more, the rules become just kind of your standard go-to. All right. Next, so what about if you have multiple, and this is where the rules really do start to help save you time. Instead of doing the changing of the number lines back and forth, back and forth, back and forth. One way to help make sense of it is if you change your direction an odd number of times, you're going to end up with a negative number. Okay, in other words, you're going to end up with a copy on the negative side of, or on the left of 0. But if you do it twice, like in the previous example, then you're going to end up with a positive number. Okay, so even values of multiplication with negative values means you're going to end up with a positive number. Odd results means you're going to end up with a negative number. And a little bit of intuition there is negative direction. If you do it, this is odd if you do it once, but if you go once and then twice, that's even. So that would be an even number. That's why you end up on a positive result. But if you do it 3 times, then you're going to take this number and you're going to end up back over here with another negative. So that's why this would be 3 negatives, like in this case. So we switched once, we switch direction again, and we switch direction a 3rd time. So we're going to end up over here in the negative numbers. Whereas here we switch directions twice, we would be over here in the positive numbers. So it's not that the rule doesn't work here. It's just it gets a little tedious thinking about flipping and flopping back and forth. Okay. All right. So, but hopefully that makes sense and it was helpful. All right. Exponential notation is exceptionally helpful in simplifying things, but there is something to be careful about. The difference between A and B is the base in A and B is different. In other words, this is -6, that's the base. And so what you're seeing here is -6 times -6. And so that's a positive 36. Now, I will say that we tend to be lazy, and B tends to be how we often write. And what we mean is this, but in reality, what we mean and what we're saying are 2 different things. So just be careful. It's a really common question, like on tests and stuff like that. That -1 times 6 squared. The base here is 6. Okay, so this is kind of bad notation here. There should be really like a -1 in front of all this. That's what's really happening here. So this is the base here is -6. That's why you're multiplying -6 times -6. And in this one, the base is a positive 6 with a negative out in front. So it's -1 times 6 squared, or -36. Okay. And again, when we have an odd number, it's the flopping back and forth. So we end up on the left side of 0. And if it's an even number, the flopping back and forth means we end up on the right side. So it's a positive value, especially with respect to your base being negative and flipping signs. Okay, I hope that was helpful. And now we get into one of the most misunderstood operations, which is division. So division is the result of looking at how many times, or the way that it made sense to me was thinking of equal groups of. So if you compare 2 numbers, A and B, what you're looking for is how many equal groups of size B fit into a group of size A. Okay. Or another way of thinking about it is that how do A and B relate? In other words, is there some number that I can multiply B by, and that product would be A. In other words, B is a factor of A if it divides evenly, and so we're looking for the other factor of A, so that when you multiply it by B, you get A. All right. So let's look at some examples. So in this case here, you have 80 divided by -4. So how many groups of size -4 are there in a positive 80? Well, there are 20 groups of -4 and size -20 and 80. Likewise, if you look here, so -15, if you're looking at -15, you're looking at how many sizes, how many equal size groups of 5 are there in -15? Well, there are -3 groups of equal size 5. Since that's a smaller number, I guess I'll draw it out one more time just to make sure. Okay, so here is 0. And what I'm saying is, and here is -15. And so this is saying how many equal groups of size 5 are there? In other words, how many times can I hop in this direction so that I get 215? Well, this is a group of 5. This is a group of 5. This is a group of 5. But these are distances, so these are positive. And so the total number to hop all the way here, well, I had to do it. I had to hop once here. That's a -1 direction. I had to drop once here, that was a -1 direction, and I had to hop one more time here in the -1 direction. So that's the total of -3 hops of size 5 to get to -15. So that's what I'm referring to when I'm talking about these equal size groups. Same thing with the -4, -20. It will look very similar to it, just the other direction. And so I hope that makes the visual helps to make sense of the idea of partitioning up the number line into equal size groups. So I was asking how many groups of this size are in this thing. Okay. Also note a more commonly misunderstood thing is if 0 is in the numerator on top here, then no matter how many size, there's never going to be a size. So it's always going to be 0. 0 divided by any number is 0. Whereas if 0 is on the bottom here, that's undefined, and I could take a quick second to explain why. So if you're dividing 0 into -8, okay, so if the number on the bottom is what goes on the outside of the house, and the number on top is what goes on the inside, so how many equal groups are there? Well, I can make this 5. 5 times 0 is 0. I can make this number 7. I can make it -10. I can make it negative e to the pi. Okay, so I can make this number anything and multiply it by 0 and still get 0. So the reason why this is undefined is because of this result. In other words, I can choose it to be anything and it's still true, but none of it is working out. It's not getting us anywhere. So it's undefined. It's not logical. It doesn't make any sense. So when we say that you can't divide by 0, what we're saying is that that produces a value that is nonsensical. Okay, that's why 0 on the denominator is considered undefined. All right, order of operations. Perform all operations within grouping symbols. Evaluate all exponential expressions. Then do multiplications and divisions in the order in which they occur, working from left to right. And finally, do addition and subtraction in the order in which they occur, working left to right. All right, so let's look at this in the order of operations. So in this case, there's no parentheses. So what I'm going to look for is any powers. So I see a 6 squared and a 2 squared. So I'm going to get 36 and 4. It's the first thing I'm going to do. Then I see a division symbol and a multiplication symbol. So doing them in order from left to right, I take 24 and divide it by 4, and that gives me a 6. I'm leaving the minus sign or the negative in front. And then I have multiplication, so I'm going to take 6 times 3, and that gives me 18. So finally, I have then addition and subtraction left to right. So 36 minus 18 is 18, plus 1 more gives me a total of 19. Okay. All right, so that's the order of operations for this problem. And with that, I hope that makes sense, and I look forward to seeing you in the next video.